Okay, so we're in section 9.8 where we have to factor and solve polynomial equations. We've done this through factoring of a common binomial factor. We've been doing this with reverse FOIL. And today we're going to introduce another way of helping us factor it out when we have more than just a trinomial. So some of the things that we have to look for is, again, we'll look for the special patterns, being able to factor them out by using reverse FOIL, or and today the fourth term is what is in that blue sign, is being able to factor by grouping, which I'll show you how to do that. So for these first examples, all we're going to do is they want us to factor out the common binomial. So here we have two values in common, which is x minus 2 and x minus 2. It's both the same. So what we're going to do is we're going to factor that out of those two polynomials. So I'm just going to, this is what basically what it means is we're going to go x minus 2 times, and we're going to have something else inside this parenthesis. And what it's going to be is the 3x and then the 4, because we have 3x plus 4. It would be like, for instance, let's forget about these things being x minus 2 and x minus 2. What if I just had 3x and I had 6 right here plus 4, and I just had a 6 right here as well? Well, we could factor out that 6 here, and then we'd just be left with x plus 4. So all we're doing is just the same thing as saying, okay, 6 is x minus 2, and that's where we get the 3x plus 4 from. It's just being able to take two values that are binomials and then factoring it out together to make them look like two binomials. Okay? So for B, I got a common, almost a common factor, which is 3. I got y minus 3, and then I got 3 minus y. So what I'm going to do here is I'm going to rewrite this. I'm going to go 9y squared times y minus 3 plus, I'm not going to do anything with changing the signs. All I'm going to do is just rewrite. So I got negative y plus 3. Okay? So I want to get it to look just like y minus 3. So what I'm going to do is I'm going to factor out a negative 1 out of this parenthesis. And by doing that, I'm going to make my 7 become negative. So if I write 9y squared times y minus 3, I'm going to go minus 7, and it's going to be y minus 3. So if I were to distribute this out here, it would look exactly the same as we'd have up top. But now I have a common binomial, which is y minus 3. So now I can go y minus 3 here, times it by the quantity 9y squared minus 7. Okay, so if let's do some factoring by grouping. And here's what we mean by factoring by grouping. I have 4 different functions here. I got x cubed minus 4x squared plus 7x minus 28. So by grouping means is I'm going to take 2 of them and put parentheses around them. I'm going to leave the plus on the outside. And what I'm going to do is I'm going to factor these 2 inside the parentheses individually. So I need to find a factor that I can take out x cubed minus 4x squared. I can take out an x squared. So here leaves me with x squared times and then it would be x minus 4 plus, what can I take out of 7x minus 28? I can take out a 7, which then leaves me with x minus 4. So here I have, again, it's just like we had up top in those first examples. So now I can factor this out because I have a common binomial of x minus 4. So now I have x minus 4 times it by x squared plus 7. And I can't factor that out anymore. So that's my answer. So if I look at B, I go, put the parentheses here. So now again, I'm going to look at it as a squared plus ab. What can I factor out of there? I can factor out an a. So it becomes a times the quantity a plus b. And I got plus, and this is already a plus b. So what I'm going to do is I'm going to put a 1 in front of it just so it helps us out. So when we see this out, when we factor this out completely, I'll show you why the 1 is significant. So here I have common binomial of a plus b, so I'm going to put a plus b times the quantity a plus 1. That's where the 1 comes in. Because sometimes you don't quite see that. So by placing the 1 there, that helps you out when you factor them out completely. Looking at example C, I have, let's look at this here and this here. What can I factor out of x cubed minus 45? I can't do anything. And neither can I do 9x squared minus 5x. So this leaves us with a little bit of a problem, but what we can do is we can change the order to help us out. So what I'm going to do is I'm going to use, see, I have my two largest degrees. I'm going to put those together. So I got y cubed plus 9x squared. And then I'm going to put minus 5x minus 45. So now let's try to group these ones. So I can factor out I can factor out an x squared here. So I can go x squared, and then I'm left with x plus 9 minus, and I can factor out a 5 here. So I got 5, but now because I have the negative right here, this is where things change inside the parentheses. So for me to get, so it would be a positive x, because if I distribute that, that would give me the negative 5x. And then I need a negative 45 at the end of the day, so, and I have a negative 5 that I'm multiplying by, so it's going to be a plus 9. Because if I were to distribute this here, I would get the negative 5x, which I would have right there, and negative 5 times 9 would give you the negative 45. So that's why the plus has to be there. And then it also is convenient that I have now common binomials with x plus 9. So now I can go x plus 9, and then times the quantity x squared minus 5. And that is factored out completely. These examples ask us to factor out the polynomial completely using all the methods. So first thing you have to identify is it a binomial, a trinomial, or something larger? If it's a trinomial, we can either factor it out using reverse FOIL or greatest common binomial factor. If it's 4 terms, like a cubic function, we first can use grouping in order to factor this out. So looks like my degrees are in its appropriate spot, so I think I can factor it out with these parentheses enclosed in it. So I got 3x to the fourth minus 15x cubed. That means I can take out 3x to the third, and then I'm left with x minus 5. Plus, I can take out a 12x here, and that leaves me with x minus 5. Again, common binomial. So now I can go x minus 5 times the quantity 3x cubed plus 12x. But now as I look at this, I can factor out more with 3x cubed plus 12x. I can factor out a 3x out of there. So I'm going to go 3x, and I'm going to get the x minus 5, which I can't do anything about. And then I'm left with x plus 4 here. So this here will be factored out completely. Looking at b, again, it's a cubic, it's a four-term function, so I can use grouping here. So now I can factor out what x squared, which leaves me with x plus 3 minus, I can factor out a 16, and this would be x plus, because of the minus there, plus 3. And this again gives us a common binomial, so I can go x plus 3 times quantity x squared minus 16. Now if I look at that, that looks like the difference of two squares, where a is x and b is 4. So now I can go x plus, I can factor this out further, so I can go x plus 4 and x minus 4. Okay. For C, it's a trinomial. But look here, I got x's in all of them. And also, they're all divisible by 9. So first thing I can do is let's factor out 9x first. So I got 9x, and now in parentheses it'll be what, 2x squared minus 11x minus 365, that would be what, 40. So now looking at 2x squared minus 11x minus 40, that looks like something I could factor out using reverse FOIL. So I'm going to go 9x here, parentheses, parentheses. I know that this is going to be a 2x. I know this is going to be a 2x. And I'm looking for values here and here where their products are going to give me 40. And so if I put 5 here and 8 here, 5 times 1 is 5. 2 times 8 is 16. 16 minus 5 will give me 11. And I need the negative value here and then the plus value here, because it's the negative 11 when it's all said and done. And can I factor that out anymore? No, I cannot. So this is factored out completely. Last thing we have is the ability to solve equations. So here I look at example A, and I got 2x cubed plus 28x squared plus 98x equals 0. Looking at that right away, I can factor out 2x. So I'm left with x squared plus 14x plus 98 divided by 2, give me what, 49. And I can factor out using reverse FOIL. Inside the parentheses, I got x and x, both going to be positive. And it looks like this is a perfect square one. So now I can use the zero product property. So I say 2x equals 0. And I only have to write in 1 because I only need one value for x to be the same, so x here is going to equal 0, and x here is going to equal a negative 7. Okay? And for b, I'm going to first get one side of my equal sign equal to 0, so I got b cubed minus 15b squared minus 54b equals 0. And I can factor out a b. So I got b squared minus 15b minus 54 equals 0. So now I have b. I can use reverse FOIL here. Excuse me. I know I'm going to have a b and a b. Since 54 is negative, one's going to be a plus, one's going to be a minus. And their differences need to be 15, but the products need to be 54. So it's going to be a negative 18 and a plus 3. So now I get to use the zero product property on 3 of them. So it's going to be b equals 0, b plus 3 equals 0, and b minus 18 equals 0. So the b equals 0, that's right there. So now b can also equal negative 3, and b can now equal negative, no, this is a positive 18. So those three answers would be the answers for example B. And that is being able to factor polynomials completely. Hope this helps. Till next time.